Okay, let's give you guys some more practice. So, in an electric circuit, the current I, this is supposed to be capital I here. The current I is inversely proportional to the resistance R of the circuit. Now, if you don't understand electricity, don't worry about it too much. Your science teacher will one day explain to you how the how current is related to resistance. Well, anyway, let me just translate this to you. So in a blah 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 blah, the current I, okay, the current I here is inversely proportional to the resistance R of the blah 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 blah. So we don't really care about whatever. All that we know is that we can extract this. The current I here is inversely proportional to, so we can say the current I here is inversely proportional. So inversely, we can immediately do this. Inversely proportional to the resistance R. So here, and then blah, blah, blah. We don't really care about this. We don't really care about this. But basically it boils down to I is inversely proportional to the resistance. Okay. And then here, if when the resistance is 2000 or whatever, the current, supposed to be capital I here, the current is 0.7. So find the relationship between what they mean by find the relationship is they want you to write it in the form of y equals k over x. They want you to find the equation that connects x and y. Okay, and then answer this question here. Well, anyway, press pause and have a go. So to do this here, well, this bit here, we can translate it as I is inversely proportional to the resistance. So when you have this kind of a relationship, you inside your mind you can visualize the reciprocal graph. Okay, so this here is your R, this here is your I, capital I here, and also whenever you have this kind of a relationship, you can also visualize I equals. Hang on, let me do this again. You can visualize it as I equals a certain constant over R. And our job is to find out this k, because whenever you have this, don't forget you get a whole family of these reciprocal graphs here, and then it's only you finding out the value of k can you find out the one particular line that represents our situation. So basically we need to find our value of k here. Now if you look at question 1 here, when r is 2000, I is 0.7. Okay, so we can use that to find out our k. So this is I here. So put the 0.7 into the I equals k over, well, put 2000 into the R. So now 2000 here. So now we can find out the value of k. So times both sides by 2000, and then k will be, hang on, let me get my calculator. Okay, so to find out k, get 0.7 times 2000, 1, 2, 3, equals this, equals 1000 equals 1400. So that's our value of k. So our k helps us to identify the line that we're interested in, the line that represents our situation. Okay, well anyway, k equals this. Well, so now we've got our equation. So whenever you're told that I is inversely proportional to R, we can somehow jump to this equation here. Okay, now that we've got our value of k, we've in effect got our equation. So I equals 1400 over R. You see, this is our equation here. Now, yeah, so 1 here. Yeah, so we've answered question 1 here. The relationship is this. Okay. Question 2 is if the current increases to 0.7, sorry, 0.9 here. So basically put 0.9 into the I here, and then what is the resistance? So once you've got your equation here, you can just put this into this thing here. So it will be, put the 0.9 into the I. So 0.9 equals 1400 over capital R. And now it's just a matter of working out the resistance. So times both sides by R. So it will be 0.9 R equals 1400. And then divide both sides by 0.9. So R equals 1400 divided by 0.9. And then jump to your calculator. Hang on. So 1400 divided by 0.9 equals 155. Let me round it off to 6. So this here, so R equals this. So this is your answer to question 2. Okay.